Lists are one of the most common ways to handle data in C#. If you read data from a file, fetch data from an API or database, display a lot of choices on a form, or have any reason to work with lots of data in memory, such as a bunch of numbers and strings or objects, chances are you're going to use a list. And you're probably going to want to arrange that data in a specific order. You're going to want to sort the data. Hi, my name is David Neal, developer advocate for Pluralsight, and this is Teach Me Tech. Today we're going to learn how to sort lists in C#. Let's start with a basic example of a list of integers. First, let's declare our list and add some numbers. Now I've sped up some of the typing. I don't actually type this fast. Now, let's print this list to the console. The numbers are printed in the same order they were added. Well, what if we want the numbers to be sorted in ascending order, from the smallest number to the largest? The good news is the list includes a sort method. If we call the sort method just before printing the list, we now see the numbers are sorted smallest to largest. What if we need the opposite, or a descending order, from largest to smallest? After calling the sort method, we can use the reverse method to flip the order of numbers. Now when we run this example, we see the list of numbers in reverse order. A list of strings behaves pretty much the same way. If we declare a list of strings and add some string values, now I'm from the South and a lot of folks around here would call these strings. Guitars have strings, your fiddle, tennis racket, fishing reel, piano, and don't forget string cheese. Running this example, we see our list of strings in alphabetical order. Now, what if, for some silly reason, we want to sort this list not by alphabetical order, but by the length of each string? The sort method has a few tricks up its sleeve. We can declare a comparison delegate to customize how .NET sorts the items in the list. The easiest way to implement this is using an arrow function, or a lambda expression. The comparison delegate takes two values from the list and returns an integer value. This integer value will be less than 0 if the first value is less than the second value, greater than 0 if the value is greater than the second, or 0 if the values are equal. To make things even easier, we can use the compare_to method to compare the length of the first string to the second string, and it will return the exact value we need to satisfy the comparison delegate. So far, we've looked at sorting integers and strings using the sort method. What if we need to sort more complex data, like a list of objects? Turns out the way we customize the sort for the lengths of strings is exactly the kind of thing we need to sort a list of objects. For our next set of examples, let's create a guitar class. We have several properties on the class, such as the brand, model, and year. We'll override the toString method so that we can print out a nicely formatted string that represents each guitar. Now, let's create a new list and add several examples. If we try to sort the list of objects using the default sort method, like we did with integers and strings, we get an error. What this error is telling us is in order to use the default sort method without any arguments, the guitar class must implement the iComparable interface. For now, we're going to write a custom comparison delegate similar to what we did with the previous string example. Let's say we want to sort our list of guitars by year. Now, our list of guitars is properly sorted. The sort method isn't the only option for sorting lists. The .NET Framework has a powerful set of tools named Language Integration Query, or LINQ. Among other things, you can use LINQ to sort lists. To sort our list of guitars by the brand using LINQ, we can use the order by method. Here we use an arrow function to return which property the order by method should use to sort the list. Order by returns an IEnumerable, so we use the toList method to return the objects back into a list. Now our guitars are sorted by brand. One of the advantages of using LINQ for sorting is you can easily chain together ascending and descending sorts. There are lots of other ways to sort lists in C#, but these examples should cover most of the scenarios you'll run into. I hope you found this video valuable. If so, give it a thumbs up. For more tutorials like these, subscribe to our channel. You can also head to Pluralsight.com to dive deeper into any of the topics we discuss here on Teach Me Tech.